Okay, so to solve this problem, we're going to make use of two pretty important identities, and yeah, that will let us simplify down this problem. So this comes from the 2018 TMUA paper 1. And the two identities we're going to have to use are, well, you can probably guess them, at least the first one. We use sine squared theta plus cos squared theta is equal to 1 for all theta. That is a pretty well-known identity. And the second identity we'll use is actually a sort of by definition. It is the identity sine theta is equal to cos 90 minus theta. The reason I say this is by definition is because cosine actually stands for complementary sine, I believe, something like that. So the idea is this angle in here is the complementary angle to this angle here, because in a right angle triangle, if we were to take sine of this angle, you know, sine is equal to opposite over hypotenuse. So we'd be looking at the ratio of this side to the hypotenuse. And if we looked at this angle, we know this is going to be 90 minus theta because angles in a triangle add up to 180. And so if we took cos of this angle, we'd be looking at the adjacent over the hypotenuse. But look what the adjacent is. Well, the adjacent is just this side over that. So this is why these two are actually equal to each other. And with this, you can make a substitution and set this also to be the other way around, which should intuitively work when you think about it. So anyways, now that we've got these two identities down, the work is essentially done for us. We just have to rewrite these in terms of sines and coses and be a bit careful when it comes to this sine 45 because there's nothing to correspond with that. You'll see what I mean by that. Let's just write it like this. So we'd go sine 0, 1, 2, up to 45, plus sine squared 89, plus sine squared 90, going up to there. And now you can see if we arrange each of the, arrange each angle with its complementary angle, like so, we can put them into pairs like this. And so this would continue up until sine squared 44 plus sine squared 46. And see, we have our sine squared 45 just on its own at the end, since there's no second sine squared 45. Now we can put this identity into action. So we'll leave the first sine as it is, but the second one, well, let's just look at sine squared 90 as an example. This is the same thing as sine 90 all squared. And then this is equal to cos 90 minus 90 squared still, which is equal to cos squared 0. So this is equal to cos squared 0. Do the same thing for all of the other ones. We have sine squared 1 plus cos squared 1 plus sine squared all the way up to sine squared 44 plus cos squared 44. And we'll just leave this sine squared 45 on the end. Now you can see each of these brackets is going to reduce down to 1 via the first identity over here. I'll just write 1 over here. So that's going to give us 1 multiplied by the number of these brackets. They range from 0 to 44 inclusive, so that is actually 45 brackets in total. Don't get confused. If it was from 1 to 44, that would be 44, and then we have the additional bracket here, so that makes 45 plus sine squared of 45. We know sine of 45 degrees is root 2 over 2. So that gives us 45 plus, going to get 2 over 4, which is the same thing as 45 plus a half, or 45.5. So there's our answer. E is the correct answer. Thanks for watching, and I'll see you guys in a future tutorial.